Hey everyone, welcome back to the Techers. My name is Surmeet, and for today's video, I'm going to start with the microcontrollers, basically because these are the main part for robotics and actually integrate your code with actual hardware. So first thing, what is a microcontroller? So microcontroller, you can find a very hard definitions or very small things on the internet, but the basic thing is they are used to control your hardware circuit through programming, in simple terms, and they are very small in size. So yeah, microcontroller. Anyways, so there are different types of microcontrollers. You can have 8051, which was the first microcontroller ever made, so which was in 1980s, hence 80, working on 5 volts, hence 5, and it was the first one, so 8051. Then there are others which are PIC or PIC, AVR, ARM, which also called ARM. They're different, but today I'm going to show you the Arduino, and we're going to work mostly on Arduino or PIC, basically because Arduinos are more open source and easy to use. I mean, I'm teaching right now kids from age group of 7 to 15 how to use Arduino microcontrollers and how to program. They're really simple and easy to use, plus they're open source. You can get the entire board made. All the other microcontrollers like the PIC or 805, you need to make the entire board and have the IDE. So yeah, so I have two boards over here. One is the Arduino Uno, and another one and here's another one, Arduino Mega. Basically, well, yeah, all the difference between all the microcontrollers is, so when 8051 was made, it was it was the first one, and it had CISC instruction set, which is complex instruction set computer, and any other thing like any small computations like adding a delay, for example, you had to follow some set of instruction like doing a for loop, and they were slower as compared to the new ones. And when the new ones came, PIC, AVR, the Arduino is AVR, or even ARM. Now those ones are faster and they have higher clock speeds. So even the PIC, now the new family of them, like there's an entire family, the newer models come out, they even have higher speeds, so they are more application specific. So choosing your microcontroller basically is all about being application specific. I mean, I'm normally teach Arduino Uno to the kids because it serves the purpose of what they are doing it. And I can be using the Mega one for the sessions with you guys, or even PIC. It all depends on your application specific, and when you're using it to build anything that you want, you need to see what purpose are you using it for. All right, so yeah, so how they are faster, how the new ones, like they're faster and they're different in instructions. Like, so as I said, for example, the delay function in 8051, you have to build it manually, but when you go to PIC or Arduino, you can just there's some commands. For example, in Arduino, it's just delay, that's it, done. Yeah, so these are certain difference between instructions. How they are faster is because they work on a faster clock speed. Now what's the clock speed? Yeah, good question. Basically every IC based or any even your computers, they work on a clock speed. So clock is a signal that every time a clock pulse is sent, it will be transmitting or computing some data. Now how does that affect how does the clock speed affect? So the faster the clock speed, faster the bits can, or the instructions can be processed, and the data transfer, the communication can happen, and the faster the sampling rate with the when you're converting analog to digital. Yeah, we'll get to all the details later on. how does the analog and digital work. So I mean, you can see this analog graph, and when the sampling needs to be done, so that happens. But you need to choose the right clock speed. If you choose the faster clock speed, your instructions are not properly processed sometimes, or if you choose the slower ones, yeah, you get a bit delay. So there, but you don't need to worry about in lower levels, but it's in industry levels. Yeah, so all the other materials that you'll be needing for programming or coding is, I have some other materials over here. One is for Arduino, for any microcontroller. Basically, you'll need a programming cable. You'll be needing a breadboard for building a circuit, like how you're doing it. I have some jumper cables over here. There are different types: male to male, male to female, female to female. Yeah, some resistors to complete your circuits. LEDs. Well, yeah, if you're doing the program with LEDs, I'll be showing the next one would be blinking the LEDs, how to control the LEDs. Yeah, basically these are some of the stuff I have. So there's a potentiometer over here, variable resistors, some capacitors. Yeah, so that's all you need to build, everything that you need to build a circuit. Basically, you can have DC motors, servo motors. Yeah, you can have DC motors and servo motors if you want to do that. And I'll be showing you how to work with all those sensors. There's ultrasonic sensors. I have the ultrasonic sensors, not to show you now, but in the future project I will show you when we are doing them. So yeah, those are the things. And next one we'll start coding the microcontrollers, and whatever we learned so far in the coding, we'll be using that and programming the controller. And as we go further so there will be we'll be learning the theory and apply the theory, so do it in practical. Right, so see you next time. All right, thank you guys.